Hello students, welcome back to the next module of a chapter called electrostatics. Now students, in this particular module, we'll be learning MCQs which are based on the concept of energy stored in capacitor, right? Now students, when I say energy stored in capacitor, we have already derived three expressions for it, right? And the expressions were U is equal to Q square upon 2C. It was also equal to half CV square, and it is also equal to half QV, right? So these were the three expressions for energy stored in a capacitor, right? Now using these three expressions, we'll be solving MCQs in this particular module, right? So let us start with the first MCQ. It says the work done in placing a charge of 8 microcoulomb on a condenser of capacity 100 nanofarad is. Options are option A 16 into 10 raised to power minus 5 joule, option B 32 into 10 raised to power minus 6 joule, option C is 3.2 into 10 raised to power minus 4 joule, and last option is 16 into 10 raised to power minus 4 joule, right? Now let us analyze this MCQ carefully. So here we are supposed to calculate work done. That means we are supposed to calculate W, right? Here again we are provided with the value of charge, and the value of charge is 8 microcoulomb. So I can say capital Q, it is 8 microcoulomb, right? Now I'll be converting this microcoulomb to coulomb, and the conversion factor is 10 raised to power minus 6. So I can say capital Q, it is equal to 8 into 10 raised to power minus 6. Right? Now again we are provided with the condenser of capacity 100 nanofarad. So I can say capacity capital C, it is equal to 100 nanofarad, and again I'll be converting nanofarad to farad, right? And the conversion factor is 10 raised to power minus 9. So I can say capital C, it is equal to 100 into 10 raised to power minus 9 farad, right? So students, here we are provided with charge, we are provided with capacity, and we are supposed to calculate work done, right? And students, whenever we want to deposit charge, we have to do work, right? And this work done is stored in the capacitor in the form of energy. So students, here as we want to calculate work done, that means we are supposed to calculate energy stored, right? So I can say in solution, I can say work done in charging a capacitor, it is equal to the energy stored in capacitor. And here we need to write formula of energy in terms of charge and in terms of capacity, right? So therefore I can say work done, it is equal to energy stored, and this should be equal to half into Q square upon C. Why we have written this formula? Because we are provided with the value of charge, and we are also provided with the value of capacity, right? Let us put the value. So I can say what is the value of Q? It is 8 into 10 raised to power minus 6. We also know value of capital C, it is 100 into 10 raised to power minus 9 farad, right? So if I substitute these two values, what will I get? I'll get W is equal to half into 8 into 10 raised to power minus 6 the whole square upon 100 into 10 raised to power minus 9, right? So if we solve it further, 8 square will give me 64, 10 raised to power minus 6 square will give me 10 raised to power minus 12, and on solving denominator you will get 2 into 10 raised to power minus 7. So this is what I'll get after calculation. On further calculating, I'll get W, it is equal to 32 into 10 raised to power minus 5 joule, which can be rearranged and can be written as 3.2 into 10 raised to power minus 4 joules, right? So students, see the options carefully. Which option is correct? Yes, option C is the correct answer, right? So this was the first MCQ which was based on the concept of energy stored in capacitor, right? Now let us move further towards second MCQ. It says a fully charged capacitor has a capacitance capital C. It is discharged through a small coil of resistance wire embedded in a thermally insulated block of specific heat capacity S and mass small m. If the temperature of the block is raised by delta T, the potential difference V across the capacitance is, right? And the options are under root of 2m into capital C into delta T upon S. Option B is m into C into delta T upon S. Option C is under root of 2 ms delta T upon capital C, and last option is ms delta T upon capital C, right? Now students, see carefully. Now here capacitor is discharged. So whatever amount of energy capacitor is having, that amount of energy will be given to resistor. Or I can say whatever amount of energy capacitor is having, this amount of energy will get converted in the form of heat, and this energy will be provided to the resistor, right? And as this resistor is inside the insulated block, there will not be any loss of energy. So I can say whatever energy is provided, that amount of energy will be given to the block directly without any loss, right? So let us start with the solution. Let us keep the options aside for some time, right? Now students, we know that what is formula for energy stored in capacitor? In terms of C and V, the formula is half CV square, right? Let this be my equation number 1. Now the amount of heat energy which is required to raise the temperature of block by delta T, it is given by the formula M into S into delta T, where M is mass, S is specific heat capacity, and delta T is the rise in temperature, right? And let this be my equation number 2. Now students, we have already discussed that whatever amount of energy capacitor is having, this energy will be lost in the form of heat, right? And this heat energy which is lost by capacitor will be used to increase the temperature of block by delta T. So I can say energy provided by capacitor and the energy required to raise the temperature will be the same, right? So I can equate equation 1 and 2, right? So therefore I can say Ms delta T should be equal to half CV square, right? Now I'll rearrange it and I'll get the value of V square. So I can write V square, it is equal to twice Ms delta T upon C, right? Now if I take square root, I'll get the value of capital V. So therefore capital V, it is equal to under root of 2 ms delta T upon capital C, right? Now let us move further towards the question and options, right? So which option is matching C carefully? Yes, option C is the correct answer in this particular situation, right students? So students, in this particular module, we have covered 2 MCQs which are based on the concept of energy stored in capacitor. So that's it for this particular module. I'll see you in the next module. Till then, keep learning.